All right, we are going to do part 2 of the notes. So we left off on this slide about upwelling, which answered question number 12 in your notes. So we are going to go through the rest of the slides and finish answering your questions. Okay, so deep ocean currents. So before I start talking about this is something called the global conveyor belt. It is an important area of ecology. So if you take an environmental studies or an ecology class, or even like a zoology class or a animal biology class, you will learn about the global conveyor belt. And so I'm going to tell you that it's not going to have a bunch of questions about this on the test. You don't need to know all the details. We're filling it in for our notes, and so you can have some background information, but you do not need to know all the details of this for the test. Okay, so there is this essentially river of ocean water that moves far below the surface. It's really deep ocean current, and then it comes up and becomes a surface ocean current. And it's caused by the changes in density of seawater. The density is affected by changes in the temperature and the salt concentration of the water, and we're going to look more in detail on that in just a minute. And this movement of water is known as a global conveyor belt, and it's really important for organisms. Migrations go on these currents, nutrients come up where these currents upwell, and so it's very important in an ecology sense. And so the question that's asked, number 13, says what causes these currents? And it's caused by changes in the density of seawater is what you should answer on your sheet. So another name for this is called thermohaline circulation. Thermo meaning temperature, haline meaning salt content. And so that's really what powers this current to flow, is changes in temperature and salt content of the seawater, so, or ocean water. So we have high salinity water that cools and sinks up here by Greenland and Iceland, and then the deep water returns to the surface through upwelling here. So the question asks you is, why is it known as thermohaline circulation? And it's because the movement is due to changes in temperature and salt content. All right, on this slide, I'm not going to read this because I'm going to explain it instead. So how does this work? What happens is we have this warm water that's coming up, and it gets up by the poles, and we know that up here it's cold. And so that water, some of it freezes and it becomes polar ice. However, that salt can't freeze in that ice, and so it's just pure water that freezes. And so there, all of a sudden you have this area of water that's much more salty than it normally would be because some of the water froze. And that water with more salt in it is more dense, and so it sinks very deep into the ocean, and it pushes as a current. Then as it comes through in its flow, it goes through this area here, which is the equator. The temperatures here we know they're hot. Okay, so that water's warming up, and as it warms up, it becomes less dense, and it's able to rise to the surface to become this warm surface flow. And then again, it gets back here, cools, keeps the salt, water freezes, and that high salt content water drops with being more dense down to becoming that cool subsurface flow. And that's how this global conveyor belt works. And that same upwelling and that process also happens around the Indian Ocean as well, again, right at that equator point as well. Okay, and there is not a question that goes with this slide. All right, our last topic is, how do ocean currents affect climate and weather? Well, we have warm surface currents that increase moisture and warmth in the atmosphere above them, and cold surface currents cool the air above them, and the movement of water and thus the winds aloft help distribute the sun's energy and in turn regulate the climate on Earth. So what we have is, in places that are along the coast, we have this stable year-round climate, tends to stay with not huge fluctuations in temperature, maybe 10, 15 degrees. But in the landlocked regions, like we are here out in the Midwest, we have these huge extreme temperature swings. You know, we always talk about it here in Nebraska, how it can be freezing cold in the morning where you need a jacket and you would want shorts in the afternoon. And that extreme temperature swing is because we don't have an ocean current that's regulating our temperature. We are prone to any jet stream that's bringing cold or warm air into the Midwest. So, the West Coast here, their current comes from Alaska and Canada and comes down across. It's the California current or the Pacific current, and it brings in cool air. They tend to have very mild temperatures. They tend to stay in the 60s and 70s. They get into the 80s and 90s, but not as frequently as we would here in the middle of the United States. Okay, and so they keep pretty regulated temperatures. Also, if you know anything about Washington and Seattle, which is along the coast, gets a lot of rain. That cool current brings that moisture in. Down here, they're influenced by the Gulf current, the Gulf of Mexico currents, and the Gulf Stream currents are very warm and wet. They get a lot of rain in these areas, and they also get hurricanes. And so they also have very regular temperatures. If I've been down here along the Gulf Coast of Texas, and temperatures were the same almost every day we were there. And my husband grew up down here and said even during the winter they stayed about the same. Part of why people like to go to Florida in the winter and go to Disney World, because it's cool, 60s, maybe 50s, but it doesn't get as frigid as it is up here. And so it feels like a break for those of us in the Midwest to come down to that Florida area for those currents. And then we also have the East Coast. Sometimes those hurricanes go all the way up the East Coast, but they also have milder weather along that coast from that those warm surface currents that give them moisture. They tend to get a lot of snow up here in the east, and rain events as well. They'll get a lot of rain and snow. They also have the benefit, some would say maybe not, that they have the Great Lakes that also bring lake effect snow to some of these areas where they can get very large amounts of snow where it'll make the news. So your question says, how is the climate of coastal areas influenced by surface currents? And you can talk about how they have more stable year-round climate. You could talk about how the West Coast has a cold current and how the Gulf Coast and East Coast has a warm current, and that affects their climate. Okay, and that's the end of the video and the notes. If you have any questions, let me know. Thank you.